We're going to do some problems identifying graphs of the tangent and the cotangent functions. And I'm going to start here by just showing you the graph of the tangent of x. And remember, tangent is the sine over the cosine, and that's going to give us some of the properties of this graph. Where sine equals 0, the function is going to equal 0. And where does the sine equal 0? Well, at 0 and at pi, and then again at 2 pi. So you can see those points here. It's also going to give us some interesting behavior where the cosine equals 0. And the cosine, of course, equals 0 at pi over 2 and at 3 pi over 2. And you can see what happens here is that the graph goes up to infinity and down to negative infinity there because the function is undefined when the cosine equals 0. So that's what makes the tangent graph have these long arms pointing upward and downward. Let's take a look at some variations on the tangent graph. Now here what I've done is put a multiplier on the function. This is actually 1/4 tangent of x. And all that's really going to do here, remember when we put a multiplier outside the cosine or the sine, we increase the amplitude. But since the tangent graph is going up to positive and negative infinity here, you don't really notice that so much. What you see is when you use a multiplier that's between 0 and 1, you see a squishing kind of this flat area down here. So it gets flatter when it's closer to the x-axis. If you were to put a bigger multiplier here, like a 3, it would get much straighter, and these would look almost like straight diagonal lines. So that's 1/4 times the tangent of x. And here we've done just a little bit more. We have 1/4 times the tangent of x plus pi over 3. Now the pi over 3 is a phase shift, right? And so it's going to go pi over 3 in that direction. So usually 0 is right there with the tangent, but we've shifted it over pi over 3. So that's the tangent. This one is one where we increased the period of the tangent, so, or increased the number of tangent functions within the period. So I think this one is the tangent of 3x. And then I also want to look at the cotangent. And what you'll notice here, let me bring back just the plain old tangent function. So there's plain old tangent. There's cotangent. So it's the same shape but bends in the other direction. They're inverse functions of each other, so they're sort of like mirror images. And then this is cosine over sine. So where cosine equals 0 would be at pi over 2, 3 pi over 2. That's where it crosses the x-axis. Where sine equals 0, like at 0, and at pi, it's going to be undefined, and that's where you have the arms reaching up to infinity and down to negative infinity. So this is the cotangent of x. And let's look at one variation. Now this one kind of looks like the tangent of x that's been maybe phase shifted a little bit, but this is actually the negative cotangent of x. So if you put a negative multiplier out in front of cotangent, you're actually switching the orientation of these arms again. So I wanted you to be aware of that. All right, let's do a couple of problems here. This first one is y equals pi over 4 times the tangent of x plus pi over 4. So a couple of things going on here. We're using a multiplier, although it's pretty close to 1, 3.14 over 4. But since it's less than 1, it should squish it, make it a little flatter looking when it's near the x-axis. And then we have just a phase shift here of pi over 4 in this direction. So instead of being at 0, 0, it should be just a little bit that way on the 0. Now, this function here, while it looks like the tangent, it's going in the right direction. It's got that shape like that. But it looks like it's been shifted down. And again, to shift a graph down, you'd put some negative number out there after all the parenthesis business, but that's not happening here. So it looks like A is out. In B, we've actually got them going the wrong direction. So this is either a negative tangent or this is a cotangent function. And let's take a look at C, because it's between C and D, which is none of these. And in C, we've got the tangent function. Looks a little bit squished, and it also looks like it's shifted pi over 4 in that direction. So it seems like C is going to be our correct answer there. Let's look at one more. So this one, they want us to find the graph of a negative cotangent of x plus pi over 2. The negative cotangent is going to look like the tangent. So it's going to have that shape rather than the cotangent shape. Here's the cotangent shape. That's a positive cotangent shape. We're looking for the tangent shape, which is this one. So that's the negative cotangent shape. The question is, has it been shifted pi over 2 in that direction? And the cotangent function is going to cross 0 when the cosine is 0. And the cosine is 0 at pi over 2. And as you can see right here, it's crossing 0 at 0. So it looks like indeed it has been shifted pi over 2 back in that direction. So B is going to be our correct answer there. Again, with all of these, if you want to double check, put in a value for x, maybe choose one that's easy to calculate the cotangent of, and see if it falls on the graph. So that's a little bit of work with the tangent and cotangent graphs.